Hey, Pre-Calc 2. I'm going to go over some more difficult equations with you. We're going to just do a couple of them, and then I'll have you play around with some, but also practice the ones that you've done before, because your next test will also be on trig equations. Then what we're going to do is we're going to do what they call the law of sines and cosines, solving for sides of triangles that are not right triangles. But let's dig right into page 704, number 76 for now. And I want you to look on with me that this is the original problem. It gets a little tricky, but it's nothing that you can't think your way through. What I'm going to do is I see what I have, and I want to say to myself, what identity is there that could help me out with this? It's saying I have a sine of some angle times the cosine of some angle comes out to be square root of 3 over 4. It's two trig functions that are multiplied together. So I go through the book and I look for two trig functions that are multiplied together. And I find on page 685 that I have this identity. So I try it and I follow the identity exactly, and I want you to do that and redo this problem. After you've done that, we're going to simplify, and here we get the sine of 0, and the sine of 0 is 0, so this one just knocks right out, and I have a half sine of 2x equals square root of 3 over 4. If I multiply both sides by 2 now, 2 on this side and a 2 on this side, the 2's over here will cancel out, and I'll get square root of 3 over 2. Well, I'm kind of familiar with that angle, and this is saying to me, for what angle is the sine equal to the square root of 3 over 2? And if we take a look, that would be pi over 3, or 60 degrees, where square root of 3 over 2 appears as the y coordinate. So that's what I'm getting. I'm getting this pi over 3. But that's not the only place. The other place where I get a square root of 3 over 2 in the y position, y coordinate, is going to be at 2/3 pi. So I have two places. So I put that one down as well. When I divide both sides by 2, I'm going to get, or multiply both sides by 1/2, so to speak, here and over here, what I get is this pi over 6. And if I did over here, I would get the 2's canceling out, 1/2 on both sides. I'd get the 2's canceling out, I'd get a pi over 3. So I have two possible answers. But is there only two possible answers? Here's the thing, is I have two functions multiplied together. Let me go back and check to see if it works. If I put pi over 6 into each of these from the original equation, I'm going to get square root of 3 over 2 and 1/2. You could check these out on the unit circle. And they do come out to be square root of 3 over 4. But what if they were reversed? What if the sine was the 1/2 and the cosine? So that would be this one here. Put pi over 3 into sine and pi over 3 into cosine, and I still get that. So I see that both of them work. But what about this? What about the angle for which the sine is a negative square root of 3 over 2 and the cosine is a negative 1/2? They would still come out to be positive square root of 3 over 4. What angle would that be where the sine is a negative square root of 3 over 2 and the cosine is a negative 1/2? Well, let's see. That would happen down in the third quadrant right here at 7/6 pi. The reverse is also true. If this one was negative 1/2 and that one was a negative square root of 3 over 2, they would still come out to be square root of 3 over 4. And what angle would that be? Oh, I had these reversed, but that would be this one here at 4 pi over 3. Still get the square root of 3 over 4 when I multiply these together, or if I multiply these together. So there's actually 4 answers to this. It would be pi over 6, it would be pi over 3, but it would also be these two down here. It would be 4 over 3 pi and 7 over 6 pi. This is what you need to do for homework. Take this problem and completely think through it again from beginning to end, and make sure you understand how we got these 4 answers as solutions for this one equation. The next problem we're going to do is page 704 again, but number 80. Number 80 looks like this. I don't know how to deal with this. We can't distribute a sign inside here. We're not allowed to distribute a function. It's not like a number or a variable. But what we can do is we could look for an identity to replace this, and this is an angle sum, and that's an angle difference. And if you look on page 679, you'll find that, and I used those identities, this one in green for that one, this one in purple for that one, to replace those things with the identity that they gave me on page 679. Go through that and see where that came from. If you have to pause this video to do it, do that. We know that the cosine of pi over 3 is 1/2, and the sine of pi over 3 is square root of 3 over 2, so I just replaced them throughout. I cleaned it up a little bit by putting the 1/2 out front and the square root of 3 over 2 out front of the cosine. And then I just try to combine the like terms. Well, this one and this one, which are these two, one's a plus, one's a minus, they completely canceled each other out, and they became 0 in the pink. In the purple, I have a 1/2 a sine and a 1/2 a sine. That makes one whole sine. So really this question asks, the sine of x equals 1. So what angle makes the sine of x equal to 1? It would be 90 degrees, or pi over 2. The last part of this is they just want to make sure you know how to use a calculator. But also when you use a calculator, the calculator will always give you the smallest answer in the first quadrant, or the smallest answer closest to the positive x-axis even. In this one, what we'd have to do is, if this were the question, we would have to take the arc sine or the inverse sine and use our second sine button to get the angle. And this is now the angle what the calculator gives me. It's in radians. And we don't often think of radians in terms of decimals. We always have it in terms of pi. But if we were to think of it in terms of decimals, look what we get. Pi over 2 comes out to 1.57. Pi is 3.14. 3 over 2 pi is 4.71. And 2 pi's is 2 of these, so it's 6.28, and then we're back to 0. This 0.8481 is in the first quadrant, smaller than the 1.57, so it's over here, this purple angle. So that would be my answer. But is that my only answer for which the sine comes out to be 0.75? I don't think so. I think over here the sine would come out to be 0.75 as well. So in other words, the opposite over the hypotenuse came out to be this. Well, this opposite over hypotenuse will also come out to be this 8481, but it would represent this angle in here. Just like on the unit circle, if you notice we have like a pi over 6 here. It's pi over 6 away from the x-axis. Well, over here it's also a pi over 6 away from the x-axis. This 5/6 pi tells us how far it is from here over to the 5/6 pi. So this is a 0.8481. Well, that's not the angle we want. The actual angle that we want is this angle here. We'll make it in pink. From here all the way over to here. And how would I get that? Well, very simply, you could do it 2 ways. You could think about, well, what would that little angle be by subtracting 1.57 minus the 0.8481 to get that, and then add another 1.57 on. Or the easier way is to get that pink angle. Let's just call it, we'll call it x again. To get that pink angle, we would go 3.14. Let's see. Let me do my colors. 3.14, which is all the way around, minus, we would go minus this green 8481. And that would give us the pink angle. I'm not sure what that comes out to. I don't have my calculator with me. But that would be the other angle on that. So just subtract these two and get that answer. And this would be that pink angle, which is what we want. So again, there's two possible answers for this. So what you should do is you should try these problems for homework right here on page 703 and 704 all the way up to here, knowing that if you want a little bit of a challenge, 97 to 116 are the more challenging problems. I wouldn't necessarily give something on a test like that. But if you're one of the students who are going to go on in mathematics, or you just like a little bit of a challenge, you could try those problems as well. But the other ones, up to 96, they do have a couple calculator ones in there, but from 1 to 96, we should be able to do every one of these problems. We need to become experts at solving trig equations. And that's what your next quiz is going to be on next, Monday, the 27th. Good luck. If you have questions, let me know. We'll have a chat on Wednesday, but be prepared to do your homework and ask me questions on Wednesday. I'll see ya. Have a good night.